Yes, sir. My name is Rajeevjee Kumar. My father name is Naveen Kumar. I am 10 years old. I study in 5th. I am from Bihar, but I am living in Ludhiana city for my study purpose. My hobbies are playing cricket and reading books. Thank you. Yes. Good evening, sir.
Good evening. Hello, everyone. Good evening. Hello, namaskar, Uday ji.
नमस्कार नमस्कार। काफी दिनों बाद दोनों एक साथ ही लाइन पे हैं।
हाँ, अच्छा। और क्या सब चल रहा है अभी उधर?
अभी ठीक है, हम लोग का थर्सडे को ग्रेजुएशन सेरेमनी था, तो अभी कॉलेज बंद हो गया है। रिलेटिव शांति है।
अच्छा,
बीच में 1-2 हफ्ता काफी हेक्टिक हो जाता है एग्जाम से पहले और एग्जाम के टाइम।
अच्छा, चलिए अभी 2 ही ब्राइट किड्स अभी हैं अभी।
हम्म।
Hello,
हाँ,
Aryan and Earth. You have any question for Uday ji?
No, sir. No, sir.
मन में शंका है, क्वेश्चन आप पूछ लीजिए, एकदम बढ़िया से समझाते हैं वो।
लास्ट वीक इंटरेक्शन किया था इन लोगों के साथ, तो 1-2
अच्छा,
सवाल थे, ज्यादा तो नहीं उन्होंने पूछा, लेकिन हाँ कुछ सवाल थे इनके।
अच्छा, मैं ही मिस कर गया लास्ट टाइम जरा सा। So, Aryan, you have any question? Acha, right now Rudra is there. So, Rudra, you have any question?
No, sir.
No, sir. Acha, Arth, you have any question?
No, sir.
तो फिर कैसे होगा? If there are no questions, where will the answers come from? रुद्र तो शायद क्लास 5 में पढ़ते हैं अभी ना?
Yes, sir.
हाँ, तो क्लास 5 में क्या पढ़ रहे हैं अभी साइंस में?
This is
क्या चीज?
skeletal and nervous system.
पूरे बाबा, ये तो बहुत डेंजरस सब्जेक्ट है। तो नर्वस सिस्टम के बारे में क्या पढ़ रहे हैं अभी?
फिर ब्रेन्स होती है और नर्व्स होते हैं।
अच्छा, तो नर्व्स का क्या काम है? क्या काम करता है ये?
Yes, sir.
नर्व्स का क्या काम है?
Sir, to send signals to brain.
टू सेंड?
Signals to brain.
अच्छा, तो सिग्नल्स ब्रेन को भेजता है, ब्रेन से भी सिग्नल जाता है बाहर, नहीं?
Yes, sir.
देखिए उदय जी, आजकल 5वीं क्लास के बच्चे
हाँ,
नर्वस सिस्टम वगैरह के बारे में पढ़ते हैं। हम लोग, मुझे याद है हम लोग 5th क्लास में कभी भी नर्वस सिस्टम नहीं पढ़े।
मेरे को याद है ये बायोलॉजी, फिजिक्स, केमिस्ट्री मेरे ख्याल 6th क्लास में अलग-अलग पढ़ना शुरू किया था, मेरे को जहाँ तक याद है। 5th क्लास तक साइंस ही होता था।
हाँ, तो इतनी तेजी से बढ़ रहा है इन लोगों का अभी नॉलेज सिस्टम।
हाँ, एक्सपोज़र भी काफ़ी ज़्यादा हो रहा है नॉलेज का, और उसके बाद दोनों चीज़ है, मतलब कि एक्सपेक्टेशन भी उनसे ज़्यादा है कि उनको ज़्यादा नॉलेज होना चाहिए।
पर एक ही प्रॉब्लम जो एजुकेशन सिस्टम में जो है कि किसी भी क्लास में क्या होता है कि टीचर जो है, तो जो ब्राइट स्टूडेंट होते हैं उसको काफी कैटर करते हैं, पर जो जो थोड़े पिछलग्गू हैं तो उनको ध्यान ही नहीं देते, तो और वो पीछे होते जाते हैं।
हाँ, इसमें एक्चुअली 2 तरह का सिस्टम इवॉल्व हुआ था, लेकिन फिर चला नहीं वो, क्योंकि उसमें एक ये था कि ब्राइट स्टूडेंट को एक क्लास में डालो, बीच वाले को एक क्लास में और नीचे वाले को, तो उसको टीचिंग अलग-अलग तरीके से फोकस कर फिर लोग, पेरेंट्स का ऑब्जेक्शन ये है कि भई तुम हमारे बच्चे को ब्रांड कर रहे हो कि पढ़ाई में अच्छे नहीं है।
हाँ।
तो उसके चक्कर में वो सिस्टम को ज़्यादा हवा मिली नहीं और वो इतना भी धराशायी हो गया। लेकिन वो मेरे को सिस्टम ठीक लग रहा था, क्योंकि एक क्या होता है कि अगर सबको एक साथ कंबाइन कर देते हैं, तो जो तेज़ स्टूडेंट है वो भी फ्रस्ट्रेट हो जाता है, क्योंकि आप एक ही चीज़ को रिपीट कर रहे हैं।
हाँ, सही बात।
हाँ, तो वो एक सिस्टम मेरे को ठीक लगता है कि हाँ, सेग्रीगेशन ठीक लगता है। लेकिन सेग्रीगेशन अपने आप में आज के ज़माने में जहाँ वोकिज़्म ज़्यादा है, वहाँ पे एक तरीके से क्राइम माना जाता है।
अभी मैं बता रहा हूँ कि मैं यहाँ पर जो है सो एक ऑर्गेनाइजेशन है, एनजीओ ही है, तो वो लोग जो है जो बहुत गरीब विद्यार्थी हैं, जो मोस्टली स्लम ड्वेलर्स जो हैं, उनके बच्चे को जो है तो पढ़ाने का काम करती है। तो वो लोग हमको एक दिन बुलाया जस्ट, तो मैंने भी जो सो कहा कि आपके 8वीं 9वीं के बच्चे को जो है सो जरा मैं देखना चाहता हूँ। तो मैंने एक छोटा-सा क्लास 3 क्लास 4 का सब्ट्रैक्शन, डिवीज़न, मल्टीप्लिकेशन जो है। हेलो?
हाँ, हाँ।
तो 8वीं 9वीं के बच्चे को डिवीज़न, सब्ट्रैक्शन, डेसिमल वाला चीज़ मैंने दिया प्रश्न उनको, और इसमें 70% विद्यार्थी नहीं कर पाए। अब सोचिए कि क्लास 8, क्लास 9 में यदि नहीं कर पाएँगे तो फिर क्या करेंगे? बहुत ही मुश्किल होगा उनको समझना कोई चीज़।
आई थिंक पंकज जी का जो है ना कम्युनिकेशन भी कम साथ में ही चल रहा है।
तो 8वीं 9वीं के बच्चे जो है सो चौथी 5वीं का मैथमेटिक्स, अरिथमेटिक वगैरह जो है सो उसको हल नहीं कर पाते। तो वो तो धीरे-धीरे पीछे ही होते जाएँगे वो तो। तो उनको तो समझ में कुछ आएगा नहीं धीरे-धीरे।
ये ना पहले ज़माने में मेरे को एक बहुत एक ऐसी छोटी-सी स्टोरी है।
हुँ,
तो जब स्टीम इंजन इंडिया में खत्म हो गया था या खत्म होने वाला था, तो काफ़ी सारे ड्राइवर्स अनएम्प्लॉयड हो गए थे। कुछ ट्रांस जो यंगस्टर थे उनको ट्रेन किया गया, कुछ अनएम्प्लॉयड हो गए। तो एक स्टीम इंजन का ड्राइवर ऐसे ही उनको पास तो मिलता ही है, ऐसे ही ट्रैवल कर रहा था इंस्टीट्यूट में। तो बता रहा था कि हमारे ज़माने में इंजन की आवाज़ से हमें पता लग जाता था कि क्या प्रॉब्लम है। क्योंकि हम
हुँ।
वो कहता था कि हम टन्स ऑफ क्या बोलते हैं, कोल फेंक लेते हैं। कोई सोच भी नहीं सकता कि इतना टन कोयला कोई हाथ मैनुअली फेंक सकता है। और उसको फेंकने के लिए हम इंजन के मूवमेंट को ही टैप करते थे कि हाँ, इस तरह स्विंग करेगा तो कम ताकत लगेगा। लेकिन उसको साइंस कभी समझा ही नहीं गया कि हमने कैसे किया। और आज के डेट में डीजल इंजन में जब तक आग का वो लग नहीं जाए इंसान कि वो जलने न लग जाए, तब तक फायर वार्निंग का इंतज़ार करता है कि फायर वार्निंग आया नहीं, मैं क्यों कुछ करूँ? तो
सही
जैसे-जैसे
बात।
टेक्नोलॉजी इम्प्रूव होता जा रहा है, वैसे ही वैसे लोग का कैलकुलेशन कर कोई भी चीज़ सीखने की क्षमता घटती जा रही है। पहले जब कैलकुलेटर वगैरह नहीं था या अलाउड नहीं था, तो लोग मैन्युअली कैलकुलेट करते थे और वैदिक मैथमेटिक्स और बाकी बाकी तरीके से काफ़ी तेज़ी से मैनुअल कैलकुलेशन होता था। मुझे
हम्म।
याद है कि साइन की वैल्यूज़ मतलब कि साइन 30 कितना होगा या साइन 45 कितना होगा या साइन 60 कैसे होगा, मैथमेटिकली ईज़िली तरीके से समझा दिया गया था। भई 1, 2, 3, 4 लिखो और उसको 4 से डिवाइड कर दो, स्क्वायर रूट ले लो। तो
हम्म।
साइन 30 हो गया 1/4 स्क्वायर रूट, हाफ साइन 45 हो गया 2/4
2 बाई
स्क्वायर रूट
स्क्वायर
दैट
रूट
इज़
ऑफ
1/2
4।
स्क्वायर रूट। हाँ,
हाँ,
तो
सही।
उसी त हाँ, तो वो उस तरीके से नंबर याद हो गए कि स साइन 45 की क्या वैल्यू होगी या साइन 60 क्या होगी या कॉस की क्या होगी या टैन की क्या होगी। लेकिन आज के डेट में अगर किसी को आप पूछिए कि भई 10 स्टूडेंट्स हैं, उनको 10 रुपीज़ पर मंथ अगर मिलता है तो कितना होगा? वो भी कैलकुलेटर बैठ के लेके करने लगते हैं। और एआई आने के बाद वो कैलकुलेशन भी नहीं करना चाहते। वो तो सिर्फ़ बोलना चाहते हैं, ऑडियो भी हो गया है, भई तुम बता दो मेरे को कितना हो गया। तो जैसे-जैसे टेक्नोलॉजी इम्प्रूव होगा, जैसे हमारे बॉडी का सिस्टम है, जो भी चीज़ हमें बाहर से मिलती है, हमारी बॉडी उसको नहीं प्रोड्यूस करती है। उसी तरह नॉलेज के बेस में भी ऐसे ही होगा, जो-जो इन्फॉर्मेशन हमें आसानी से मिलेगी, हम अपने ब्रेन को ट्रेन करना भूल जाएँगे।
अच्छा, ट्रेन करने की बात तो जो है, अभी अभी आप सुने होंगे, अभी एक 80 साल का मैथमेटिक्स का प्रॉब्लम जो अभी तक सॉल्व नहीं हुआ था, उसको एक मशीन ने कर दिया है, एआई ने कर दिया, सॉल्व कर दिया। न्यूज़पेपर में बड़े जोर शोर से आया था ये।
हाँ,
80 ईयर्स से अनसॉल्वेबल था वो, नो ह्यूमन बीइंग कुड सॉल्व इट, तो उसको एआई ने सॉल्व कर दिया। तो धीरे धीरे जो है सो मशीन जो है सो अब ह्यूमन बीइंग्स की तरह होने जा रहे हैं।
एक्चुअली क्या है कि मशीन का जो ट्रेनिंग है, वो उसी कॉन्सेप्ट पे बेस्ड है कि हमारा ब्रेन भी ट्रेन होता है। तो हम अपने
हम्म।
ब्रेन को ट्रेन करना बंद कर देंगे, तो ऑब्वियसली हमारा ब्रेन काम करना बंद कर देगा ना वो चीज़ें। और
सही बात
धीरे-धीरे हम चीज़ें पहले अधिकतर बच्चे कंट्री और कैपिटल को जानते थे। जस्ट बिकॉज़ वो कंट्री कैपिटल को जानते थे, उनकी ज्योग्राफी भी जानते थे। वो जानते थे कौन-सा कंट्री कहाँ पे अभी है। अब धीरे-धीरे जब सब कुछ प्लेटर मिल रहा है, तो लोग बॉदर्ड भी नहीं है कि कौन-सा कंट्री कहाँ है। जब ज़रूरत होगी तो पूछ लेंगे एआई से।
है।
तो अब धीरे-धीरे ज्योग्राफी, मैथमेटिक्स ये सब चीज़ बेसिक चीज़ें हो रहा है और ये प्रॉब्लम इंडिया में स्पेसिफिक नहीं है। यूएस में भी लोग देख रहे हैं कि जनरल जो है लोगों का नॉलेज डिफरेंट क्लास लेवल पे जिस लेवल पे था उससे पीछे जा रहा है।
हम तो चाहेंगे कि इस प्लेटफॉर्म पर जो बच्चे आते हैं वो सोचना सोचें, वो पढ़ाई लिखाई करें और बढ़िया से उसको ब्रेन को जो है तेज करें। सरवाइव करने के लिए यही एक तरीका है।
हाँ, ऐसा है एजुकेशन सिस्टम को आप देखें कैसे एजुकेशन सिस्टम बना था, तो पुराने ज़माने में जब सिर्फ फार्मिंग होती थी और स्किल देख के या हल्का-फुल्का बता के होता था। जब इंडस्ट्रियल रेवोल्यूशन आया तो लोगों अगर सीखे ना तो उनका हाथ-पैर कटता रहता था क्योंकि चीज़ें तेज़ी से मूव करने लग गई थी। तो उनको ये बताना पड़ा कि भई ये चीज़ें ट्रेन करनी पड़ेगी, मशीन को कैसे हैंडल करना है, क्या करना है और उसी समय फॉर्मल एजुकेशन सिस्टम, स्किल बेस्ड एजुकेशन सिस्टम का जन्म हुआ और उसके तरीके से ही पूरा चीज़ बना कि इंडस्ट्री को ये चीज़ चाहिए तो बच्चे को वही चीज़ पढ़ाया गया। इंडस्ट्री में का मतलब कि ऑफिस खुल बंद शुरू होने के लिए कोई सायरन बजेगा या घंटी बजेगी, वही स्कूल सिस्टम में शुरू हुआ। वो सिस्टम आज तक वैसे ही चलता आ रहा है। तो धीरे-धीरे आदमी को सोचने की शक्ति खत्म हो गई और वही लोग सक्सेसफुल हुए जो ये सिस्टम फॉलो नहीं किए। अधिकतर पैसे वाले लोग बहुत पढ़े लिखे नहीं है। पढ़े लिखे लोग ओवर ए पीरियड टाइम ऐसा समाज बन गया कि जो ज्यादा पढ़ा लिखा है उसकी ज्यादा इज्जत होगी। लेकिन पढ़ाई का सिस्टम इतना बेकार होता गया समय से कि हर आदमी को एक टनल में घुसारता चला गया और टनल के अंदर ही वो चलता चला गया, उसको टनल के बाहर कुछ दिख ही नहीं रहा था। टनल विजन हो गया उसका बिल्कुल ही। तो आदमी अधिकतर जो सक्सेसफुल आदमी है वो बाहर से देखना के शुरू किए, वो टनल के बाहर देखना शुरू किए तो दिखा दुनिया इतनी बड़ी है बाहर, बहुत कुछ हो सकता है। तो आप देख लीजिए जितने पढ़े लिखे लोग हैं, देयर इज अ डिफरेंस बिटवीन नॉलेज एंड विजडम। नॉलेज पढ़ के आ सकता है लेकिन वो विजडम नहीं आ सकती। और अधिकतर पढ़े लिखे लोग अनपढ़ लोग के नीचे काम करते हैं, क्योंकि अनपढ़ लोग के पास विजन होता है जो कि पढ़े लिखे लोग के पास विजन खत्म हो जाती है, वो चैनलाइज इतना टनल विजन हो जाता है। अब मेडिकल साइंस में देख लीजिए, आपको एक डॉक्टर जो है एक सॉल्यूशन बताएगा और उससे आपको दूसरी बीमारी हो जाएगी। एक क्लासिक एग्जांपल देते हैं लोग, एक प्रॉब्लम है पल्मोनरी एम्बोलिज्म, जबकि आपका लंग्स में ब्लड क्लॉट होता है। इसका कारण जो होता है बॉडी के अंदर एक डीवीटी करके होता है, डी वेनस थ्रोम्बोसिस। तो आपके अगर पैर में अगर ब्लड ब्लॉकेज है तो पैर के अंदर आपके जो ब्लड वेन्स हैं मोटे होते हैं कंपेयर टू एनी अदर पार्ट ऑफ द बॉडी। वो लॉजिक तो सिंपल है। तो अगर वहां कोई ब्लॉकेज है और किसी कारण से ब्लॉकेज क्लियर हुआ तो उसके छोटे छोटे टुकड़े आपके पूरे बॉडी में सर्कुलेट होने लग जाएंगे और सब सर्कुलेट होते होते वहां जाके फंसेगा जो सबसे पतला ब्लड पाइप है, जैसे कि कैपिलरीज है, और लंग्स में फंसने के चांसेस काफी ज्यादा होते हैं, तो आदमी मर जाएगा। ये इसकी सबसे ज्यादा चिंता कार्डियोलॉजिस्ट। लेकिन जब आदमी के हार्ट में ब्लॉकेज होता है, वही कार्डियोलॉजिस्ट जो सबसे ज्यादा इस चीज की चिंता करता है, वो ब्लॉकेज क्लियर कर देता है। वो ब्लॉकेज क्लियर कहाँ होता है? वो तो ब्लड में रह जाता है और छोटे टुकड़े में हो जाता है। वो छोटा टुकड़ा और घूमता रहता है पूरे बॉडी में और वहां जाके फंसता है जो सबसे छोटी पाइप होती है, वो कहाँ होती है? ब्रेन में। तो कार्डियोलॉजिस्ट जब आपका ब्लॉकेज क्लियर करता है तो आदमी हार्ट अटैक से नहीं मरता है, ब्रेन स्ट्रोक से मर जाता है। और न्यूरोलॉजिस्ट कहता है आप तो मेरे पास कभी आए ही नहीं थे, तो मुझे कैसे पता रहेगा आपको ब्रेन स्ट्रोक होने वाला है? और कार्डियोलॉजिस्ट कहता है देखो हार्ट अटैक से तो तुम नहीं मरे थे।
वेरी नाइस। अच्छा, ये मुझे भी नहीं पता था। ये ठीक आपने बताया है। ये अर्थ आपसे कुछ क्वेश्चन पूछना चाहता है। हेलो अर्थ, व्हाट इज द
हाँ,
क्वेश्चन?
So I have a question about science. That if air is invisible, how do we know it exists?
Invisible?
So if air is invisible, then how we know that it exists?
अच्छा,
actually there are eye is just one of the 5 sensory organs. There are other sensory organs that allows you to feel it. Air has its own pressure, you can feel it. Whenever air blows, you can see the leaves moving around. There's air blowing, you can feel the chill in the wind. And if you measure the pressure of the air, you can also see whether air exists or not. Because in vacuum, the pressure is going to be different as compared to the pressure when there is air.
So I have another question.
Yes.
what is that?
So why does a steel chip float while a small iron nail sink?
दोबारा क्वेश्चन कहिए तो क्या कहे?
सर अगर एक स्टील का चिप पानी में तैर सकता है तो एक छोटा सा आयरन का नेल तैरता क्यों नहीं है?
कोई भी चीज को तैरने के लिए यू हैव टू सी कि उसका जो डिस्प्लेसमेंट है, एयर वाटर का डिस्प्लेसमेंट है उसके वेट से वो कितना ज्यादा होता है। तो बड़ा सा शिप जो होता है वो अगर स्टील का है तो ज्यादा पानी को डिस्प्लेस करता है, और जो निडल है या नेल है वो नहीं करता है।
अच्छा अर्थ, ये क्वेश्चन आपके दिमाग में कैसे आया है ये?
सर बस वो देखे थे आज एक यूट्यूब पे, तो उसी पे से आया।
अच्छा, हेलो सत्यजीत।
Hello, sir.
या
Sir, I'm from Odisha, India, and I'm currently in 12th grade.
where are you in Orissa?
Sir, Kalahandi.
Oh, so you study in a Oriya medium school or a English medium school?
No, sir, it's English medium.
Okay. So you are coming for the first time in this one, no?
No, sir, I have joined twice earlier.
Acha, twice earlier. So
Yeah.
today you have. Do you have any question to ask?
No, sir, I just visited, wondering what's happening.
Yes. So in class 12, you have taken up science.
Yes, sir.
So, presently, what is the subject that I mean, chapter that you're reading in science?
Sir, I
Say
have,
physics. Say physics. Or
sir,
hello.
majorly our syllabus revolves around electricity this year.
So you are able to understand what the teacher teaches you about electricity.
Yes, sir, it's currently the starting of the 12th, but two topics in physics is what fascinates me the most. One is electricity and the other is light.
Okay. So electricity. Have you understood what is electricity?
No, sir, not that deep.
No, roughly you might have an idea. The people say there is electric current flowing. So what is it that is flowing actually?
Uh, they say it's the flow of electrons, basically.
Yeah, but why does it flow?
Um, because of the difference in charge, I mean, potential difference. That's what make them flow.
तो सत्यजीत, आपके दिमाग में ये एक प्रश्न आया कि पोटेंशियल डिफरेंस होने से कोई चीज फ्लो क्यों करता है?
Sir, I would say like pretty much the same case we see in the flow of air, which happens due to the difference in temperature. So that's my assumption. One at a place we have higher potential of electrons, higher number, and at the other end we have lower, then that makes the difference, which makes it flow to make it balance.
Okay. No, but something they must have told you that. What do you mean by potential, first of all? Potential difference is the potential at one place and potential at another place. So what is the difference between them? So what is this potential actually? I'm just asking. It's possible that maybe you might be covering this in future. I think maybe your teacher will tell
Yes,
you.
sir, as per now, I assume it to be electrons. I mean, if there is a lot of electrons at one place, that doesn't sound obviously right, but I haven't really think about it yet.
Yeah, you must. So in science, the one to learn science, the best thing is that keep on asking deeper and deeper things.
Yes, sir.
So what is the potential difference? So why do the electrons flow? So these are the things, the more you ask, the better will be your learning actually. But in class 11, which are the subjects you learned in, say, physics, chemistry?
Sir, I was a PCB student, that is physics, chemistry, and biology.
Yeah.
So
So
we omitted maths because I am preparing for NEET.
okay.
Yeah.
So in physics or chemistry, what did you learn in class 11 then?
Sir, in class
What are the
11,
topics they covered in class 11 actually?
sir, in 11th, we have topics like gravity, Newton's laws of motion, and then we have more of a mechanical perspective of physics. And we had fluid, we had heat, and those stuffs. And in 12th, we just have two topics majorly. One is electricity, and the other is light, and some semi topics such as semiconductors and atoms. That's a part of physics also. But in 11th, we basically had more of a mechanical part.
Okay. No, mechanical part means it was more about. Actually, you said gravitation was taught to you, and
Yes, sir. Gravitation,
gravitation, and
Newton's laws of motion.
so did the teacher make you understand what is Newton's law of motion?
Yes, sir.
What is that? No, I think
Um,
we are just we're gossiping, so you don't have to be very serious and very accurate. Just, I mean, what is your understanding of Newton's law?
Sir, it were there were three laws, and they explained the daily motions of everyday things around us.
Yeah, which were those three laws? I mean, why do people always talk about Newton's laws of motion? What is great about that?
They deal with the regular motions we see in daily life. I mean, they explained velocity and the calculation of speed, distance, and these stuffs also. So I guess that's one aspect.
Mhm. So, what is
Uh,
the first? I'm just asking. Just I want to understand. What is the first law you learned there?
First law was the law of inertia, and it
Mhm.
stated that.
What that means? Well, suppose you want to explain to someone who is say in class say 7, like Earth is in class 4 only, and here we have got Aryan Rudra is there. He's in class 5. So how will you explain to him what is the first Newton's first law?
So, Newton's first law is also known as the law of inertia. And what inertia basically means in layman terms is the tendency of an object to restore, I mean, to keep its motion as it is. I mean, the state of motion can be two, either it can be moving or at rest. So, the tendency of an object to preserve that thing in it is known as inertia. So it basically stated that until and unless we applied an external unbalanced force on an object, it tends to keep that inertia in it. So if let's say if a ball is on the ground and it is at rest, so until an external unbalanced force acts upon it, it won't move. And why unbalanced is the big term? Because external can be also balanced. So in the balanced case, we do not see motion either. So it must be external because the internal cannot make it move. And the other criteria is to be unbalanced. So that is basically the Newton's first law in a nutshell.
Yeah, yeah, very good. I think so. So your teacher was really good. That's yes, they have made you understand. And what about the second law?
Second law, sir, was more like a technical one. So it gave the formula of F equals ma, and in theory, it stated something like the force on an object equals to um, I actually had memorized the line. So
Force is equal to mass into acceleration. Yeah.
yeah, but yes, sir, but it had a whole theory line which I had memorized. So yeah,
Yeah,
in
yeah. Can you tell us what is it that you have memorized? You see, you try to memorize something if you don't understand it, but that's okay for the exam. But in real life, unless you don't try to understand that, then you'll get into problems. So what is it that, yeah, please tell us about the second law, I think.
Uh, so in second law, we saw a derivation which stated that force is directly dependent to uh, F equals ma. So mass into acceleration. Acceleration is the change in velocity.
Hmm.
And so force is directly proportional to the rate. Yeah, yes, sir. So the force is directly proportional to the rate of change of velocity in the direction of.
No, you're correct. Satyajit, you're correct.
Yes, sir.
Yeah, you're
So
correct. So
then
now my question to you is that there is Earth and there is Sun. So Sun is also applying a force, gravitational force.
yes,
You
sir.
have already read about gravitational on the Earth. So why
Yes.
the Earth doesn't fall onto the Sun?
Sir, because it has some orbital velocity for which it is locked in its own orbit. So if let's say Earth were static and Sun was also static and there were no motion going on in between, then the Earth would be falling into the Sun. But because the Earth is in such a perfect position that it is orbiting the Sun as well as is locked in its orbit, so it's in a suitable position. So that's why it tends to orbit, and there are a lot of things that do not tend to gain this ideal motion, so they tend to either go off track or fall inside. We see a lot of asteroids and comets come and go. So that's answer.
No, but I didn't get the. No, what do you mean by locked? There is nothing called locking. I mean, there is Sun and there is a gravitational force. Obviously, the Sun is not telling the Earth that please get yourself locked. Sun is just applying a force on the Earth. And by the way, Earth is applying the same force on the Sun.
Yes, sir.
That is what the third law said, isn't it?
Yes, sir. Yes, sir.
So, but first that we will take up later. But then why you think that this Earth should not fall?
Um,
There is no locking device. I mean, you're thinking that there is something called locking. What is that locking you mean?
no, this assumption came when I actually first saw the fabric description of space-time. Like they explained space-time as in the rubber sheet. So they show a demonstration where if you put a ball and it bends, so you put another small ball and it tends to fall straight on the bigger ball. But if you give some initial velocity to the smaller ball and just push it a little, then it tends to revolve and then slowly get inside. So that's my very rough assumption that the Earth must be going in such a speed that it tends to revolve and not fall. Though I'm not sure.
No. The answer which you have given, you should be sure about it. It's correct. It's the correct answer. But yeah. So no, actually,
I
the
really
Earth.
haven't think that much about
The
it, sir.
fact is that Earth is really falling towards the Sun, but the amount of fall is such that it compensates. That the distance still remains the same. I'm talking about a circular orbit. It is very
Yes, sir.
surprising. So if suppose I'm standing on the Earth and I throw a ball if, with some speed, then after some time the ball will just fall down. If I increase the speed, the ball will still go further. If you increase the ball speed to such an extent, you will find that you will meet with that the ball keeps on revolving around the Sun. That means the fall which is there. So fall which is there, it just compensates and remains in circular orbit.
Okay, sir, I can imagine. So it basically compensate to the curvature of the orbit. So it
Yes,
basically
curvature
falls
of curvature
altogether.
of
But
yeah. So then it keeps on
yes,
revolving round and round. So
yes, sir, I got it. But I really hadn't think about it this way.
So, yeah, that's so you're doing a good. You're a very good student.
Thank you, sir.
But never try to memorize anything. Physics is not for memorizing. Just for go on, keep on understanding them. Go deeper and deeper. Ask questions to yourself, to your teacher. Sometimes you can come to us. There are very knowledgeable people. Udayji is there, and many other people are there. Any doubt which you don't get cleared, you can come to this platform and we try to clear them. If you ask a very difficult question, we will try to answer you next time.
Yes, sir. Thank you, sir.
Yeah, because we are also in the learning process.
Yes, sir.
And try and
Sir,
to
where are you from?
understand where I'm from.
Yes, sir.
I'm from Kolkata.
Oh, my father was a professor
Yeah,
there actually.
yeah. Your father was a professor here, and I was a student of Ravenshaw College in Cuttack.
Oh, that's beautiful.
Now, who else wants to ask it? You want to ask any question, then you are free to ask. Or
Okay,
else,
sir. Yes, sir. I'm just looking over my syllabus once, then I will ask, sir.
yeah, Rakesh has a question. Rakesh.
Sir, I'm Saksham.
Oh, you're Saksham. I'm sorry. Saksham, what is your question?
Sir, my question is how does temperature in gases rise so abruptly compared to solids and liquids? Like gases can be trillions of degrees hot, and does friction occurs in them?
Oh, a very difficult question.
Can you repeat the question?
Yeah.
Sir,
Can you
my
repeat
question
that?
is how does temperature in gases get so hot like trillions of degrees Celsius, unlike solids and liquids, and does friction occurs in gases?
First of all, actually, even solid and liquid, if you raise the temperature, they will become gas. Okay. So they cannot exist at a very high temperature. The solid will melt into liquid, liquid will evaporate into gas, depending on different temperature. And the, there is more friction in solid, less in liquid, and very little in gas. So the friction does not happen because they are well separated. If you compress them together, they will again go back into liquid and solid.
So, sir, then why does temperature of gases can be extremely hot? You can say trillions of degrees Celsius, like near a black hole, also.
That's what I'm saying. Anything at higher temperature will become gas. So that is the only three states that we talk about. Okay. So they have to exist in some state. That state happens to be the gas. They cannot exist in a solid state or liquid state at that particular temperature. And as far as the friction is concerned, because the gases, the electrons and atoms are well separated from each other, there actually very little friction in that.
Sir, can you explain it in which examples?
Okay, just the classic example is ice, water, and gas, water vapor. Okay, if we heat ice, it will become water. If we heat water, it will become water vapor.
Okay, sir.
No, sir. Sir, no, sir. No, sir.
Sir, this question arose some days back when I was reading regarding atoms, and it was what actually causes radioactivity.
Hello. Yeah, Satyajit, what's your question?
Sir, what actually causes radioactivity in atoms?
Yeah, this is a question. उदय जी, आप इसको आंसर करना चाहेंगे?
Actually, radioactivity basically happens if the atom is unstable. So that time the energy is released. So everything is over a period of time, they start decaying. And anything that decays releases radioactivity.
Yes.
Okay, I
Sir,
think Uday ji has answered you, but let me just add a deeper a little bit into it. That there is something called weak force
yes, sir.
inside a nucleus, where there are neutrons and protons. So there is a exchange of W and G bosons, they call it, and sometimes they how to say that this. A neutron, by exchanging these bosons, they change to proton and things like that.
Yes, sir.
So this decay which occurs, that produces this radioactivity in the nucleus. So it is the weak force which is responsible for this radioactivity.
And so this decay
I mean,
happens in just unstable atoms.
yeah.
And this instability increases as we go later in the periodic table.
That's true. Yeah, any like say even say, let us say for the most of the, suppose the different isotopes of the any element, many of them they become radioactive. Say, I mean, it becomes, as such everything, will decay, but some like say proton will decay in so many unimaginable, years. But many isotopes of different elements, they decay because of the instability. The
So sir, the
That is a
one
good question. In fact, the same question was asked by Aryan few days back. Were you satisfied, Aryan, that time with the answer?
Yes, sir.
So, what was the answer?
Sir, it was because of the number of the imbalance between the ratio of neutrons and protons. So what happens that the neutron does does decay and becomes a proton by the weak nuclear force.
Yeah, so you get alpha, beta, and gamma. Gamma ray comes, that's anyway is a neutral thing. But you can get an alpha coming out and a beta electron coming out. But this happens due to weak force. And can you imagine that weak force is working in your body too?
Yes, sir. I had a question.
Okay, just one thing before this. I have another meeting at 11:30. So 11:25, I'll just leave.
Okay.
Oh, what is the time in your place now?
It's 11:20.
Okay.
Okay.
Another 5 minutes.
Sir, I had a question. So,
Yeah.
whenever something falls into a black hole, its event horizon increases. But, sir, why does that happen? Because when that specific object gets absorbed by the singularity, it should be compressed into a point, into an infinitely small point, and its mass would be infinite. And if it's infinite, how it's and if I throw something in it, why does that black hole then increase in its area?
Aryan, this is a very difficult question for me. I don't know whether Udayji will take this question.
Can you please
Actually,
repeat your question properly?
Whenever something falls into a black hole, why its event horizon increases?
Okay, so
actually,
do you first of all you need to tell us that what is a black hole.
Yeah,
Yes. No.
okay.
Yes, Aryan, before you are asking the question, now there is a question to you. What is a black hole?
So when something gets compressed to its singularity, it becomes a black hole where the escape velocity reaches the speed of light.
Okay, so do you know how the size of black hole increases?
When something falls in it, but I do not have like an intuition how does that happen, because the the singularity is an infinitely small point which has infinite mass. So if we are just adding in some mass to infinity, why does that increase? I got, so that's my question.
Means you are asking that why does the mass of the singularity increases?
Like how does that event horizon increased? How is my question was that?
So means your question is how does the size of event horizon is increasing, right?
Yes.
So as per your question, anything that falls into the black hole takes its mass and gains it. So as the mass of the black hole increases, its size increases. And you also know that this boundary of the black hole is known as the event horizon. So as the size of the black hole increases, its event horizon will also increase.
Okay, so like that particular object got absorbed into the singularity, right? So singularity is a point, is an infinitely small point, and it has infinite mass. So it's like adding mass to infinity, and that increase the area of that event horizon.
Yes.
How is that infinity plus something is equals to bigger infinity?
okay. Uh, I'll I'll just tell you one particular thing. First of all, there is nothing like infinity. Infinity is when number is very large, we just say it's infinity.
Okay.
Okay. So if the number it becomes even larger. So when we say infinity, we assume that there cannot be anything bigger, but that's not the case. We generally use the word infinity loosely for very large numbers. And if number is very small, we generally tend to say zero. So, the probability of what you call it, gamma rays hitting us, or probability of quasar hitting us is a non-zero probability. But we say it will not happen. So very small number is considered as zero, very large number is considered as infinity. So he's right. As the mass increases, so will the gravity increase, so will the light will stop escaping the black hole, and so will the horizon increase. Okay, I'll just excuse myself for this particular from this
Okay.
particular group now.
Thank you very much, Uday.
Thank you so much. Bye.
So sir,
So, Aryan, this was a very difficult question, by the way.
I had one more question. So what? So like if
No,
we
but there is one question from Satyajit. He wants to ask.
okay,
No, sir, and let Aryan go ahead first.
Achha, okay. So, Aryan, go ahead first.
okay, sir. So my question is, whenever like let's imagine that there is a desert, and if we move anywhere like 60 degrees, that desert would be same. And if what we can do is that we can rotate the whole desert so it looks symmetrical, but that symmetry breaks when we add an object, so that is called rotational symmetries and time translation symmetries. So our universe does not follow that, but in a black hole what happens at the singularity, uh, what happens that may I think so these symmetries may be true, and like in the heart of a black hole they may be true, and in the outer universe they are not true. So so what so if so sir, am I right, like inside that the space time curvature is infinite, so it's uniform everywhere if we take a particular uh, section of that black hole, so that should follow the translation and rotational symmetries.
But you just said that you are assuming the point to be infinitely small. So how are you treating symmetry there?
Can you, what did you say?
Well, you did assume, right, that the mass of the singularity as well as the size would be infinitely large and infinitely small, respectively. So the mass would be infinitely large and the size would be infinitely small, like a point mass.
Yes,
That's what you said right earlier.
yes.
So how are you treating symmetry in a point size mass object?
Okay, if we look at the point, we rotate it, nothing changes, it's still symmetrical.
Yeah, but it is a point, right? So how are you going to rotate it?
Okay, so if I
Singularity
look
is
at
a
that
point, right?
point from any angle, that would be symmetrical. That's symmetrical.
So that proves you are not treating it as a point because you are rotating it and you cannot rotate a point.
Like if we look at from any angle, that will say see the same point.
I'm not sure about that you can do like.
Oh my God, two great young scientists are talking, and I really don't understand neither the question nor the answer. I need to read it.
So symmetry is something you see in 3D objects and 2D objects, right? And a point is not either, it's not 2D or 3D. So that's what I'm trying to make my point is.
So is every singularity is different from each other, right?
Well, if you treat one singularity as having, as it is something having infinite mass as well as infinitely small size, then you're basically treating every singularity out there the same because you are treating everyone having infinite mass. So you cannot differentiate based on size or mass because all of their mass is infinite and all of their size is also infinitely small as per your assumption.
So if we look at an electron, it's very small and it's considered to be a point in space moving. So is that electron symmetrical? Because it's not even a point. Uh, it's way too small to measure for us. So is that symmetrical?
No, but every electron have the uniform charge, but in universe, in the universe scale, you see black holes that are larger from other and you see black holes that are much smaller. So we don't see that uniformity in black holes as not in the case of electrons. So that is one part you can differentiate.
So, Aryan, you are satisfied with what Satyajit has answered?
Yes.
So,
So
we have
it's
a
not an
question
answer.
also.
It's just another perspective of the question. I actually don't have the answer of it, and I'm wondering the same thing actually. What Aryan asked, that a mass going into the black hole shouldn't really affect the original mass of the black hole. So why it
Yes.
expands its event horizon? That actually strike my mind as well.
There I was reading a book. Uh, I think so. Brief.
Yeah, the brief history of time.
No, the brief. There's another book of Einstein. I think so. I kept it here. Yeah. It's about Stephen Hawking's brief answers to big questions. So I was just reading this, and in this, the black holes chapter came. So I was just wondering about that.
Oh, I'm about to purchase that book actually. I have this brief history of time, and I was looking for that book.
So it was so he couldn't finish this. So his family members published it for him. He died
Yeah,
about 7 months before publishing it.
Lucy Hawkins should be a part of it, right?
Yes, yes, yes,
But
yes,
all of you, when you read Stephen Hawking, he was much ahead of our times actually,
yes.
and he has written things which can not yet prove.
So he had warned about Donald Trump's election and many more things like AI. He also wrote about AI use, good use of AI.
Yeah, in fact, Stephen Hawking also said before his death that if we don't shift from Earth to some other planet, then in 100 years,
Yes,
the
yes,
whole thing, the Earth, all the human beings will vanish.
yes, sir. He said that we shouldn't hold all of our eggs in one basket. I remember that.
So yeah, he was a great scientist. There is no doubt about Stephen Hawking. There are many things which he said he has come out to be true, but most of the things which he said are yet to be proven. So we have to wait. There could be an error in it. There could be many things. So
So,
we
sir,
have to be very careful in science. You see, I can propose a theory. Suppose you are a young person, you will read my book, and you will feel that what I'm saying is correct, but then it's not correct. So
yes,
you have to be very careful.
sir. But what Uday just said, I also think that uh, the number is very large, but we use infinity, uh, like for an exaggeration. But the mass is finite, but very large. And I also think that, and I had one thought that if we keep giving the black hole and specific type of charge, it would eventually become full of that charge, so it may repel that specific charge. So I was just thinking about that. So is that true?
No, I don't know. I can't answer this question because I haven't read much about it. So I can very, my understanding is very simple about black holes. These are quite in-depth questions.
Yes,
So one needs to go through it. But what I'm saying is that be careful in science that we have got many theories, they come and they go. So you have to be very careful. Unless there is an evidence of something, we should not believe in it. And you certainly cannot make an argument based on things for which there is no evidence. So you have to be very careful. See, there are so many models, standard models, so many models are there that there is 11-dimensional universe, 36-dimensional universe. So many things are there,
yes.
but
So,
those are all propositions. There is someone, I think, who has raised the question first? Saksham
so,
or Satyajit?
It was Sakshan, sir.
Okay, Saksham, what is the question?
Sir, my question was, we know that as we fell matter into a black hole, it will release out some radiation. So how does it happen?
So it will give out a radiation. Yeah. Yeah, this is a good question. Who wants to answer this question? Because you are defining black hole as something that radiation cannot come out. So why does radiation come out from black hole? Who wants
Yes,
to answer this question?
sir, I think so. I can try. So what could be the case is that the when a star falls into a black hole, what happens? That there is some material left around the uh, uh, accretion disk, and if there's a lot of material, it eventually gets heated up, and it almost travels at the speed of light because of the acceleration provided by the black hole. So that may cause the emissions by black holes after eating something.
Satyajit, you want to attempt this question?
I don't have any idea, sir. Sorry.
Okay, no, yeah, Aryan, what is that is the present theory, but let's wait whether it
Yes.
let's wait whether it comes out to be true. Who knows? It may be true.
Sir, I had another question. The original question when I was asking regarding radioactivity, I hadn't actually finished there yet. So my original question was if, as Udayji mentioned, that it is basically due to the instability in the atom. So as the unstable nature of atom increases as we go uh, like forward in the periodic table, so the most radioactive element should be the 118th element, but the most radioactive element on Earth tends to be polonium 210. So why is that the case?
No, can you repeat this question?
Sir, his question was that when an atom gains extra things, it should become more radioactive. So he's saying that according to this logic, the last element, osmium something, it should be the most radioactive. But the case is that polonium is the most radioactive. So why is that?
Mm, You're saying that the polonium is the most radioactive. When the most by most, what do you mean actually?
Sir, I just randomly typed it and searched it the most radioactive element, and it tends to be polonium 210. So it obviously isn't the 118th element because yeah, it is not 118th. But according to the logic, the unstable nature of atom grows with as we go up in the periodic table, go ahead. So those last elements should be the most radioactive ones, unlike uranium and thorium and those elements.
So actually, as we grow, that part is not correct. Like say uranium 204, I think 204 is a very
Yes.
stable element. So even in one element, there are different isotopes are there, and they have different half life. Basically, when you are saying stable, you are talking about half lives. If that is what you're meaning, the stability means half life. If some element has got one isotope of one element is suppose half life is something, and then another isotope is different. So they have got different stabilities.
So I'm not
Uranium
aware of
two,
half-life.
uranium 204. I just for example, like the uranium 235 is unstable, but very hard, large half life.
Yes, sir.
But uranium 233 is not that stable, and uranium 204 is very stable.
Sir, I'm not aware of this half-life concept. I mean, we have studied isotopes and
Half
also,
life is something in any material. The time taken, suppose radioactive decay takes place.
Yes.
So suppose you start with 10 gram. So because of the decay, it will be losing materials like say alpha particles. So it is losing in mass. So by the time its mass becomes half, the time taken to reach half mass is called half life.
that must be a big period of time, isn't it?
No. For some, it is few milliseconds, even less than milliseconds. Even there are particles. Their half lives are in terms of nanosecond.
So they
So
become half in mass in just
highly
couple.
unstable, and there are elements with stability. Like say, proton is something 10 to the power 30 years. I think proton. The proton is very stable. but the figure might be right or wrong, something, but it's very high, a huge figure.
I used to think of stability as the following nature of filling up the octet rule.
No, it's different
So
from.
the octet rule, which you are saying, is 2n square rule, is it? That is what you're meaning?
No, sir. When electrons of other atoms combine with the others to make a shell of 8 electrons, that is the
Yes.
octet.
Yeah, that comes from formula 2n square. So if n is 1, then 2, 8, and n is 3,
Yes.
means that 18. So this is the octet rule. Most of the elements go for the 8,
Valency. Yes, sir.
8. Yeah. Yes.
So
Valency.
we are talked about the stability of atoms in this manner. Half-life is totally a new concept to me.
Okay, wait. Radioactivity. So I think so. He's talking about electron valency and these ionization energies.
Yeah, basically the stability of atom, that these are the factors that determine it. That is what we are taught.
No, that is for the electron
Yes.
stability you are talking. Yeah. But,
Yeah,
no, I'm
so
talking about the nucleus stability.
yes.
Radioactive.
So when the nucleus decays, though, the electron doesn't play any role.
Yes.
See, like say the radium, when it was emitting alpha, beta, gamma rays, it comes from the nucleus. The question arises, why does it come from the nucleus? That's because when the neutrons and protons are there in a nucleus, there is a weak force acting and which causes this. This instability comes because of that. And it is probabilistic in nature.
Yes.
Nobody can predict that now the thing will come out. We still don't know.
Yes.
But
Sir,
if you take the average, then you have some idea like half-lives and all these are the averages.
Sir, Mrityunjay Bhaiya is joined.
Mrityunjay, he has
Yes.
got a nice space
Yes, sir.
astronaut in his. Hello, Mrityunjay.
Good evening, sir. Good evening, everyone.
Yes, good evening. You have come after a long time.
Yes.
Yes, sir. How is everyone, sir? How are you, sir?
We all are fine. How are you?
I'm great, sir. I'm great. My
Where are you
engineering.
now? Where are you
I'm in
now?
Bangalore. I'm in Bangalore, sir.
Yeah, and doing what?
I just completed my engineering. My last exam was 2 days back, and so as of now, I'm having holidays, working on some papers right now.
Papers regarding what?
On astrophysics, sir. I have done one project internship, so I'm working on that paper on solar chemistry.
Oh, good. But then you did engineering or you did astrophysics?
I did engineering degree, but I did
Huh.
my internship in astrophysics in protoplanetary disk.
Yeah, it's nice. I mean, you are doing engineering as well as doing astrophysics is a very interesting subject. See,
Yes,
people like Dirac. Dirac, he was an electrical engineer, but he was so much interested in physics that all life
yes,
is spent on physics. But he was actually an electrical engineer, and because his family wanted that he should become an engineer, so he became an engineer, but he didn't leave physics.
yes.
So you will all to you also the same thing will happen, is it?
Hopefully, sir, with all your blessings.
Good, nice. No, you see, I mean, you can take up any profession. There is no, but science is something that it is a lifetime. You can take interest in that, and you can sometimes come up with very nice ideas and good papers.
Yes, sir.
Professionally, you can become anything. Profession See, you have to take up a profession where you can earn money. You see, that is, you have to survive first. So to
Yes, sir.
survive, you have taken up a profession, but your interest lies in physics. So that you can keep on doing.
Yes, sir.
So, so Saksham is there, is it?
Yes, sir. He had a question.
Saksham is asking a question. Someone raised a question now.
Yes, sir. I think section is there.
So Mrityunjay, you should keep on coming because we want astrophysics answers from you. Our young
So,
scientists, they have got very nice questions, very difficult
sure,
questions.
I'll be joining. Yes,
Sir, I have a question.
Acha, you have a question, Saksham. What is that?
Sir, my question is, even though Uranus and Neptune have similar amounts of methane in their atmosphere, the color of Neptune is much more vivid than of Uranus. Why is it so?
What did he say? Actually, no.
Sir,
Today
he
there is
said,
some. Yeah. What is that?
sir, he said that the gas proportions of uh, Uranus and Neptune are pretty much the same. Like the gases methane are pretty much in the same ratio. So why is there a color difference?
Oh my God, this is a question I can't answer. Now, who can answer this question? Mrityunjay, you want to answer this question? It's a very difficult question, by the way. Acha, are
yes,
you
sir,
sure
actually,
that both the compositions are same? Because
He said
I,
pretty similar. He said
I don't know whether it is same because if it is same, then the color has to be same.
yes, sir.
I don't think it is like pretty similar. It is similar, but not pretty similar to have the same amount of colors, same color different or means appearance.
Saksham, let me try to read the books and tell you actually. I will see the photograph and I will see the composition, then I'll tell you.
Sir,
But by
Yes,
the
yes,
way,
so we need to look upon it.
Acha, you people must answer to me one question which none of you have answered yet. Or is it that you answered that why the sky is blue and why in the morning time it is reddish and yellowish? Why it is so?
uh, sir, I think so. Uh, it's blue because of the oxygen and nitrogen that is present in the air. Uh, uh, in the past of the Earth, it wasn't the same color. It was because of these nitrogen fixing bacteria. They
Nitrogen, a bit louder, Aryan. Yes.
they were bacteria which released gases into the atmosphere, and that caused the atmosphere colors to change. And in the daytime, the color is different because that specific tone of light reaches us more.
No, no. So first of all, why it is blue? What did you say?
Sir,
Because of oxygen and nitrogen.
yes, sir, because of the gases.
No, but I can tell you one thing that there is something called Rayleigh scattering.
Yes, sir.
Rayleigh scattering says that the lower, higher the frequency, more is the scatter. So in that case, instead of blue, we should have violet. The color should be violet because violet
No, sir.
color has got more frequency.
Sir, it
Satyajit
also
wants to
depends.
answer this question. You want to answer, Satyajit?
Sir, I'm not sure about the second part, but yeah, I was wondering the same thing. But as per the first part, why the sky is blue, we actually studied this in class 9th, and
Hmm.
as you sir said, it was all about scattering. So when the shorter blue wavelengths of light, they basically tend to scatter more longer than the red and orange wavelengths. So this scattering occurs as the sunlight passes through the Earth's atmosphere. So and but at the same time, the color changes at different time. That is totally because the angle at which the sunlight enters the atmosphere.
Yeah, you're very much
So
correct.
due
But my question is now Rayleigh scattering says that The higher the frequency, more is the scattering. Now, if you see
Yes,
the
sir.
Vibgyor, then VIB. So the frequency of violet is more than the frequency of blue. So the sky should be violet, not blue,
Sir, I think
because
so.
the frequency of violet is more.
Sir, I think so. It also depends on the material that it's scattered off.
Yeah, that we are talking that it is mostly nitrogen and oxygen. So that we have fixed. So, आप लोग
Sir,
this, can you take this as a home
yes,
task and answer me next time?
sir, I had recently saw a shorts regarding this very same topic, and it has something to do with the eye sensitivity of humans, I guess.
Eye sensitivity. Okay, well, okay. That means you are saying that
Eyes
our eye is
sensitivity
more
system.
sensitive to the blue.
Yes, sir. Then the violet. That's why we perceive the sky as blue.
Okay, let us keep this question on hold and maybe next time we discuss this question. Someone should come with a complete
Sure, sir.
answer. थोड़ा सा research कीजिए आप लोग. We'll discuss this question. अच्छा, okay, there is a question
Ji,
from
sir.
Saksham. Last question, Saksham.
Sir, I have one question that why does rainy clouds are black?
Yeah, this question I asked and you were supposed to answer this.
Sir, I wanted
Okay.
your point of view.
Not point of view. I had asked this as a home task, so you have not done the home task, all of you. Did you get the? Okay, this is the second question which you have to answer next time. So why the rainy clouds they appear black?
Sir,
We are a monsoon, so you will see that they are black clouds. Why they become black?
sir, I will.
So ये दो question आप लोगों के लिए home task है. You have to give me total answer without in a very simple way.
Sir, I had an opinion-based question. So, uh, a question is, do you think that science needs God?
Acha, no, Aryan, this is a very big question, and maybe next time we start with this question.
Okay.
Okay, I think so. We can go on, and of course, we would like to discuss this question. This is also very important. Maybe Mrityunjay also will have an opinion on this. But Mrityunjay, I remember that you were interested in telescopes also, isn't it?
Yes, sir.
Are you still pursuing that hobby? Is it?
Yes, sir. I'm pursuing.
Because I was interested in getting one telescope for a school.
Okay, sir.
So can you guide me a little bit where to get it in a less price?
Sir, what kind of telescope you want? You want refractor or reflector?
No, I haven't decided yet because I want to for a school actually I want to have. But I
Okay, sir.
want to some of my friends we are going to donate one telescope to a school.
Okay,
So
sir.
so what kind of telescope it should be so that it is one can easily do things, which brand, which where to get and all that. If you can guide us a little bit, you have very good experience in it.
Sure, sir. I'll help you regarding that.
Yeah,
Uh,
yeah. So I'll
yes.
I'll put you this question in the WhatsApp thing to you.
Okay, sir.
So okay, and then I'll get into it. So should
Sure,
we
sir.
call of day today? You have got two questions for the home task. Why the raining clouds are black and why the sky is blue? It should be violet.
Yes. Sir, can you give me your number? Cause if I had any questions and any presentations or meetings, so I can share you the link.
Yeah, yeah. My number is there in that WhatsApp group, no?
Okay, sir. I'll see that.
Or you can send me a hi, then I can I don't then I will send you my number.
Okay, sir.
Oh, okay. Then let's say good night.